Statistics and probability.
Welcome to our new topic in statistics and probability. Central Limit Theorem. The competencies for this topic. First, we need to illustrate the Central Limit Theorem. Then define the sampling distribution of the sample mean using the Central Limit Theorem. And lastly, solve problems involving sampling distribution of the sample means. Now let's start with our first activity. So for activity number 1, given the scores of 90 grade 11 students in an 80-item mathematics proficiency test, do the task given. So here are the scores of 90 grade 11 students. So what are the things you need to do? First thing to do is you select 30 scores from the set. After, you solve the mean of the 30 scores that you selected. Next, you solve the variance. And lastly, you solve the standard deviation. Pause for a while and I will give you 10 minutes to answer. God bless.
A few moments later.
Welcome back. I guess you already have your answers. So you're done selecting 30 scores from the set, then solve the mean, the variance, and standard deviation. And now I will share to you my answer also. So I picked 30 scores from the set, and here are my answers for the activity number 1. So for my 30 scores, so these are the numbers or the scores that I have selected. So for the mean, in order for me to solve for the mean of this sample, so I have to add the 30 numbers and divide it by 30. So when I add 10, 20, plus 23, plus 26, until 74, so we have there, divided by 30, the mean is 44.6. How about your answer? Okay. So for letter C, solve for the the variance. So in order for us to solve for the variance, we square the 10. So we have here 10 squared plus 20 squared plus 23 squared plus 26 squared plus 30 squared plus 30 squared. So all the scores, all the 30 scores that I have selected, and so on and so forth until 74 squared divided by 30, and then the answer for that will be subtracted to the square of the mean in letter B, and my variance is 228.17. How about your answer? And for our standard deviation, it's just simple. It's the square root of our variance, and my standard deviation is 15.11. How about your answer? So I believe we have different answers because we selected different 30 scores out of the 90 scores given. Congratulations for the first activity. You've done it well. Let's move on to our second activity. So we need to complete the following statements with the best answer. So you'll choose your answer from the given terms inside the box. So here are the terms. We have here sample, sampling distribution, sampling error, population mean, sample mean, and standard error of the mean. For the first one, the difference between a sample mean and a population mean is due to blank. So you choose your answer on the box. So which term will fit or the best answer for number 1. For number 2, the mean of these sample means equals blank. And lastly is the standard deviation of all possible sample mean is called. So I'll give you 2 minutes to answer. God bless.
A few moments later.
Welcome back. I believe you already have your answer. For the first statement, the difference between a sample mean and a population mean is due to sampling error. You got it? Very good. And the next one, the mean of these sample means equals population mean. Very good. And lastly, the standard deviation of all possible sample means is called correct standard error of the mean. And now let's discuss about central limit theorem. The central limit theorem states that the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger, no matter what the shape of the population distribution. This fact holds especially true for sample sizes over 30. So a sample size is small if its number of sample is less than 30. So a sample is large if its sample size is over 30. So central limit holds especially true for sample size over 30 or samples or large samples. So to explain central limit theorem, we have here three different graphs of n equals 4, n equals 25, and n is greater than 30. When you say n equals 4, meaning the number of samples in your or the number of respondents in your study or in your survey or any form of research is equal to 4, we can see there the shape of your graph is not like a bell shape, not like the normal distribution shape, which is a bell shape. So it's far from a bell shape. So if n is equal to 4. If n equals to 5, meaning your sample size is 25. So looking at the graph of when n is 25, the shape of your graph is a curve shape, almost a bell shape. But when your n is greater than 30, so it almost or look like a bell shape. So that's how the theorem works. So meaning if your sample size is over 30, it holds or it approaches a normal distribution as the sample size gets larger. So looking at the graph, when n is 4 until when n is 25 and n is greater than 30, the shape of our graph is forming towards a normal distribution graph, which is a bell shape. So an essential component of the central limit theorem is that the average of your sample means will be the population mean. So we already have that one in our activity number 2. And similarly, if you find the average of all the standard deviations in your sample, you'll find the actual standard deviation for your population mean. So this further suggests that your sample will reflect the characteristic of the population. Our third activity. So for our third activity, we have to determine whether the given sample is large or not. So based on our discussion, when can we say a sample is large or when can we say a sample is not large? So for the first situation, the school guidance counselor of Kabancala National High School is interested in the mean IQ scores of all senior high school students. So she decided to have 50 respondents. Is her sample large or not? Number 2, a science teacher of Kabancala National High School wants to compare growth of plants under sunlight and without sunlight. He used 10 plants for this experiment. Is his, is his example large enough or not? And number 3, a group of scientists want to determine the efficiency of the new vaccine against COVID-19. They want to use this vaccine to 2,000 patients. So I'll give you 2 minutes to answer and we'll be back.
A few moments later.
Welcome back again. So I believe you already have your answers for this activity number 3. So for the first situation, correct. The answer is large because it's greater than 30. How about the second situation? Very good. Not large, or you can have small. So, because he used only 10 plus, which is less than 30. And very good, large. So, I guess you already know sample is large if the sample size is greater than 30. Let's move on to our fourth activity. In this activity, we have here a table about the length of the wings of our housefly. So it's common to us having houseflies. So we have here the length of their wings. So our activity, first you need to organize this course into frequency distribution table with 10 class intervals. So we have here the 36 to 37, 38 to 39. So you count. So how many 36 to 37 based on the data? And how many are in 38 to 39 based on the given data? And second is you construct a histogram based on the data or on your frequency distribution table. I'll give you 10 minutes. God bless.
A few moments later.
Hello, and now let's reveal the answer for our activity number 4. So, the first task is that frequency distribution table. So we have here the frequency distribution table. For the interval 36 to 37, there are two. We have 136 and 137, so there are two items under this interval. And therefore, items under 38 to 39, and so on and so forth. And for the histogram of this activity, so we have here the intervals at the horizontal part, and for the vertical, we have the frequency. So for 36, 37, the frequency is 2. Then for 38 to 39, 4. And 40 to 41 is 10. And then we have there 40 to 43. And we have the rest of the intervals. And looking at the graph, can you describe it? Very good. Yes, it is in bell shape. Moving on, we'll discuss about the z-score. So the z-score is also the number of standard errors of the sample mean is from the population mean. So here, the z-score formula for sampling distribution for sample mean is different. So we have here the z is equal to the sample mean minus the population mean all over the standard deviation divided by the square root of the sample size. So here, unlike with the previous z-score, in our previous study, here we have a different formula for our z-score. So, how to use this formula? So let's have some examples. Example number 1. So all grade 11 students of Kabankalan National High School took an admission test and obtained a mean score of 82 with a standard deviation of 12.5. If a random sample of 100 students is selected, determine the standard normal value of the sample having a mean score of 80. So let's start with the given. Our sample mean is 80. So our population mean is 82 and our population standard deviation is 12.5. And our sample size based on the situation is 100 because there are only 100 students selected. Then for the solution, we just use the formula z is equal to the sample mean minus the population mean all over the standard deviation divided by the square root of the sample size. So we have there, when we substitute it, 80 minus 82 over 12.5 divided by the square root of 100. So 80 minus 82 is negative 2. then divided by 12.5, and the square root of 100 is 10. And then we have there negative 2 over 1.25 because 12.5 divided by 10 is 1.25. So negative 2 divided by 1.25, the answer is negative 1.6. Thus, the mean sample 80 or the sample mean 80 corresponds to the normal value of or standard value of z, which is equal to negative 1.6. And now let's have our second example. For our second example, suppose all adult male basketball players of Kabankalan National High School have a mean height of 165 centimeters and standard deviation of 6.2 centimeters. The heights are normally distributed, which is often the case with body measurements. What is the probability of randomly chosen team of 36 players with a height of greater than 168 centimeters? So we are looking for the probability that our sample mean is greater than 168. So first we will solve for z-score for sampling distribution of sample means. So our given here, our sample mean is 168 centimeters. Our population mean is given also, which is 165. Our population standard deviation is 6.2 and the sample size is 36. Using the formula, we have here 168 minus 165 divided by 6.2, which is divided by the square root of 36. And the square root of 36 is 6. So we have there 6.2 divided by 6 is 1.03. And on our numerator, 168 minus 165 is 3. So we have here 3 divided by 1.03, we come up with 2.9. So we have here our sample mean, which is greater than 168, corresponds to the z greater than 2.9. So let's try to illustrate this in our standard curve. So looking at our standard curve, 2.9 is almost at 3, and then the probability of getting 168 is we have there the area under the region which is in yellow or orange color. So we can say that based on the illustration that the probability should be less than 0.5. So we use our z-score table. So 2.9, so we come up here using our z-table of 0.9981. The value here we subtract 1, so it will be subtracted to 1. So 1 minus 0.9981, so the probability of our sample mean greater than 168 is 0.0019. This further suggests that it is almost impossible or surprising to have 36 players with a mean height of greater than 168 centimeters. Now, it's your turn to do the solving. So for activity number 5, we have here solve the problems. For the first problem, a study shows that children watch television by an average of 40 hours per week with a standard deviation of 12 hours per week. If a sample of 100 children randomly selected in Kabangkalan 2 Elementary School, determine the standard normal value of the sample having a mean time of watching TV of 45 hours. And for the second situation, we have here the weights of female grade 11 students of Kabangkalan National School are normally distributed with a mean of 47 kilograms and a standard deviation of 2.5 kilograms. If a sample of 80 female students are randomly selected, what is the probability that their weights is lesser than 48 kilograms? So I'll give you about 15 minutes to answer this.
A few moments later.
Hello, I guess you already have your answers for this activity. So now let's reveal the answer for these two problems. So let's start with problem number 1. So our given here, our sample mean is 45, while our population mean is 48, our standard deviation is 12, and our sample size is 120. With the use of our formula, so 45 minus 48 for our numerator, we have here negative 3. For our denominator, the 12 divided by the square root of 120. The square root of 120 is 10.95, and 12 divided by 10.95 is 1.096. So, negative 3 divided by 1.096 using our calculator is negative 2.74. So meaning our 45 hour corresponds to z, which is equal to negative 2.74. Moving on to our second problem. So for our second problem, we are looking for our probability which is less than 48. So first we will solve for the z-score for sampling distribution of sample means. So given that the sample mean is 48, our standard deviation is, our population mean is 47, and our standard deviation is 4.5, and our sample size is 80. Using the formula, for our numerator here, 48 minus 47 is 1. For our denominator, 4.5 divided by the square root of 80. So the square root of 80 is 8.94, and 4.5 divided by 8.94 is 0.503. So for the whole fraction, so 1 divided by 0.503, using our calculator, our z is 1.99. So then our sample mean less than 48 corresponds to our z, which is less than 1.99. With the use of a standard curve, so 1.99 is almost at 2. And then less than 1.99, so we shade it. And then the color orange or yellow there is the area that we need to solve, or the probability. So looking at the illustration, so our answer should be greater than 0.5. And to exactly know the value, we'll use the z-table. So looking at the z-table 1.99, we have here 0.9767. So our probability when our sample mean is less than 48 is equivalent to 0.9767, or 97.67% probability or chance, or to have our 80 female students of a mean of 48 kilograms. So if you have some suggestions, comments, and queries regarding our topic, just give your thoughts under comment section or directly ask me through Messenger. Thank you. See you next topic. Bye-bye.